A very good morning, good afternoon and good evening to all the participants, students and all those attending this MOOC NPTEL course. The title of which is Application of Forecasting, Regression and Time Series Models, and a warm welcome from my side. My good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you know, the three main topics which we are covering in this course, which is for 30 hours, 60 lectures, each week of 5 lectures. The main topics are forecasting, second is regression and third is time series. So, we are doing the last part, which is time series analysis, and this is week 11, lecture number 53. So, the coverage as we started in the 51st and the 52nd, we will still continue with the examples and introduction. Now, the classical decomposition of any model, and we know if it is a linear in nature, obviously that is of the form, and just write it down. So, you have x basically which is the random variable dependent on time, subscript time, MT is the trend component. So, now if you remember the trend component which we have been discussing in forecasting, we did a lot, is basically the average increase per unit time. Just let us keep it very simple. Trend would obviously have nothing to do, if we are trying to separate, would nothing have to do with seasonality, nothing has to do with cyclicity. So, the other component is seasonal component, which as usual is denoted by S with this corresponding suffix, and the random noise generally we denote by epsilon, is basically in the case of very simple linear regression or in forecasting, we have considered that it is normal with 0 mean and some standard deviation. Now, the question may immediately arise that in nonlinear regression we did consider other type of distribution for the errors, namely the t distribution with n degrees of freedom, where n can be large such that you will have almost the standard normal coming into force, and other one being the uniform discrete distribution with mean value of 0 and some variances which you can act upon or you can handle, as we have shown in the Excel slide. So, our aim is what? To estimate the deterministic component M and S corresponding to the trend and seasonality, and use properties of y t using stationarity and probabilistic model. And what I mean by stationarity for the errors would basically be whether the errors have a variance, and whether the variance, because obviously because it is a mean value is a non-deterministic part, it will have a variance, whether the variance are dependent on time, whether it keep increasing or decreasing, but in all the cases we will see it keeps increasing for the time series one. So, calculate the properties of the error and use above two of these purposes for prediction and simulation of x t, which is the value of y, the random variable which is of interest to us. Now, in doing so, we actually need the autocorrelation covariance function and autocorrelation correlation function. So, autocorrelation and autocovariance functions provide a useful measure of the degree of dependence among the values, because what we have is only the time series and you are trying to find out what is the relationship with respect to the variances and the correlation, and obviously we know correlation is always between -1 and +1. This ACVF and ACF plays an important role in predicting future values of the series in terms of the past and the present value. So, utilizing the ideas and the properties of the present and the past, we try to basically predict for the future. Now, what are the simple properties which we will try to utilize later on? For autocovariance function ACVF, for any h means basically a small unit of time, the value for the autocorrelation function when h is 0, that at present is the maximum, which is the second bullet point which has been mentioned, when h is 0, and for any value of z the corresponding this value which you have for gamma for all h, that is absolute value of ACVF at any lag. So, h is the lag. If you remember, in the case of forecasting, we use the concept of lagged, and that was given by the symbol k, and obviously means how many future times you are trying to basically predict, considering the lag or the dependent structure is there. So, let me continue reading it. Gamma h mod of that is less than equal to gamma 0 for all h, which are the lags, that is the absolute value of ACVF at any lag h is bounded by the variance of the process. So, obviously, the lag would not exceed that, and the auto covariance function is greater than equal to 0, which is the maximum value is attained when the lag is 0. That means, you are trying to predict for itself. Also, the corresponding idea of autocovariance, the structure which you have is symmetric, which means for any lag positive or negative would remain the same, meaning the covariance for a positive lag is same as equal to the negative lag, and we will see that. The second point is the auto covariance function is positive semi definite. That means, for any time series or time indexed t 1 to t k, and they are given by the time points, and for any function h is, if you remember, is the lag which is dependent on t, the value of this function would always be greater than equal to 0, and semi definite, positive semi definite means it is greater than 0, and semi definite means it is greater than equal to 0. Obviously, if it is greater than 0, it would be a definite function. Now, coming back to autocorrelate function, which is important, we will plot it, and I will come to the data series within few minutes in the Excel sheet, if you remember, which will be shared with you all. And the autocorrelation function, we have plotted it using MATLAB. I am not going to go into the details of the small, not there is a not code, is a library function in MATLAB, it is not needed, I will only discuss the output. So, autocorrelation function with lag h will be given by this factor, which is the autocovariance function for lag h divided by the autocovariance function for lag of 0. And obviously, as mentioned, the autocorrelation function is always between -1 and +1, both inclusive, and we have seen that in general statistics, which is basically the DADM 1 course, which I teach in NPTEL MOOC. There it consists and gives the idea that correlation is between -1 and +1. Now, we would have a stationary process if and only if the autocorrelation function is equal to autocovariance function with the correlation constant being 1, and we will consider that in the diagram. Now, what I am doing? So, there are two charts, and if you read the charts, these on the x axis have the lags, lags means the h. So, depending on what is the time frame, lags can be 1 day, 1 week, 1 month. So, I am taking 1 unit at a time, and depending on the data how it is been put, and on the y axis you have the sample correlation, and sample autocorrelation function is being plotted. So, for a lag of 0, as obviously as I mentioned for in the last slide, for the case it is 1 for h 0. What would that mean? It would mean that we have a stationary process, in the sense it can be made stationary, even if it is non-stationary, it can be converted into stationary process. And what is this plot? I will just I will show you the data. So, the data is there in the Excel sheet. Now, if you remember, I need to basically zoom in a little bit more. So, the data values are visible. On the first one, you have the time series analysis of Indian rupees to US dollars, and given from 1973 to 12th September 2025, the huge set of data. Now, obviously, there are missing data based on the fact when there is a holiday and Saturday, Sunday. So, those can be ignored considering that the price of Friday would be the best predictor for the price of Monday. But even if they need to be filled up, you can use just simple interpolation techniques to find out the prices in Saturday, Sunday. The next one is the UK population from 1838 per year till 2023. By the way, when you get the Excel sheet, the URL would be given. So, if somebody is interested to check the data, he or she can do that. The third one is time series of international airline passengers starting from January 49 per month till December 60. So, it is available in ITL this US government site. The next one is Australian monthly electricity production from Jan 1977 till December 1994. Then you have the passengers arrival, departure and transit at Frankfurt airport from January 2015 till December 2024 per month. So, all these are per month except for the case when you have the data for the stock market. Now, let us consider, say for example, the airline passenger data. So, if I plot it, this is the histogram. So, I need to basically decide on the bin size, so this is how the distribution would look like, and if the fit if you have, it would be just a one which slowly falls down like this. That means, tapering more onto the right hand side, and it will be mentioned as skewed distribution accordingly. Now, if I consider, I will remove this. If I consider the Australian monthly data, oh by the way, sorry, I only plotted the histogram. Now, how it would look like a time series, that was the main idea. So, if I plot it, I have not finished it, give me some time. Yes. So, this is the diagram for the case where you have the for international airline travel. And obviously, if I see very interestingly, there is a trend. I am just drawing the trend accordingly, and if you see there is a cyclicity which is going up and down. This cyclicity you will also find in another of the data which I will come to that later on. So, this is the time series plot for the airline travel, and based on that I have done for the autocorrelation function. So, if I try to find out the time series first for the electricity one consumption. So, if I plot it, this is the electricity consumption. Again, very interestingly, there is a trend and the cyclicity. I just zoom in a little bit more for better appreciation of this diagram by all of you. So, there is a cyclicity, it goes on. So, the data would be there, obviously you can work on that. So, I am deleting it because there will be other diagrams to show, and you can use the data as I mentioned to find out how the time series behaves. Okay. Now, if I come to the case for, that was the Australian monthly electricity requirement. Now, I come to the passengers, and here it is interesting, but the passengers numbers which you have seen in the airline industry, I am only concentrating on Frankfurt. The pattern shape would be same, but there is only one important point which I should mention, and that should be easily discernible by all of the participants who are attending this course. So, this is for Frankfurt airport. Now, if you see again there is a trend starting from January 2015 till about January 2020, and later on from February the trend is also, the trend is increasing, but there is a trend. Now, why this huge jump? Because that was the year when COVID stuck. So, you see the number of passengers has decreased, but interestingly the cyclicity which you have pre-COVID and the cyclicity which you have post-COVID are almost the same, but the trend is more because maybe on an average people are travelling more through Frankfurt. Now, these were all related to actually non-financial time series. I will take one of the financial time series, but you understood how the trend, what was mentioned by trend, what was mentioned by cyclicity are all there. I will just take a small set of data. So, there may be some not filled up gaps, do not worry about that. So, if I consider this is the time series of stock price of rupee to dollar. See, here is the fluctuation, and very interestingly for Indian rupees US dollar starting from 1973 till almost few days back, and all the, as I said, all the links are given where you can actually download the data. So, you see that initially the increase was steady, then and then now there has been a lot more fluctuation. Maybe it depends on the economic condition as world gets integrated starting 2009, diesel petroleum product price and other things basically affect. So, these are the examples of the time series which we are handling. Now, with that I will go back to the slide. Now, if you see, the first one is the sample autocorrelation function which we have plotted with HCF values with the lags along the x axis are for the airline data, number 1. So, you see that it is 1 and the lags basically are, if you watch it very carefully, of a difference of 12 month, 1 year, and the fall happens. So, it will be the same pattern like with the maximum lag being projected by a 1 year gap. So, past 1 year data considering monthly would be the best predictor or the maximum information would be available. This I do it for the Australian one, and very interestingly this has a negative pattern in the sense that obviously this is one as per the concept of stationary non-stationary which you have discussed, and you see the maximum value is occurring at about 10 month. So, obviously, there is a difference of 10 month period which you will consider as the maximum lag information being given. But interestingly for the later time period, as you go increase the lags, it becomes negative, that means the relationship would turn out to be negative and not positive. Now, these were the examples which are shown. Now, let us go to further discussion. A strictly stationary time series would be true if you have, say for example, the time series based on x 1 to x n, and the corresponding distribution for x 1 to x n would exactly be equal to if you basically delta change the distribution or the values of time period t by h is basically a lag. So, if you see the last two graphs of HCF, if the pattern based on the lag, maximum lag, if it is repeated with the cyclicity, with the trend, then obviously you would have a lot of more confidence in stating that these two random vectors which you are generating have the same joint distribution function, because they are coming from the same distribution based on which you are trying to predict the time series. Now, what are the properties? The random variable x t are identically distributed, that these two vectors have the same distribution function which I mentioned. Now, if for the time series it is weakly stationary if and only if that the second moment is less than 0 less than infinity, which technically means that you would basically have the variance. Now, this is important in the sense that for all t, and I will mention why it is important. Now, consider the function is like this, there is a trend. Now, if I consider this time series which I am drawing theoretically, the variances are bounded between this green maxima minima, but if the variability is like this. So, there is a trend obviously, but interestingly the variability is increasing, which means at any point of time t the variance can explode. So, that would not be true for the weak stationarity, because the second moment or expected value of x square would be bounded and less than infinity. Weak stationarity does not imply strict stationarity, which is true, and IID sequence actually, if there are independently identically distributed series, would be strict stationarity, which means we have to find out what is the IID and check the properties, and then we can only say that the property of strict stationarity is true or not. Now, every second order stationary process is either a linear process or can be transformed into linear process by doing the transformation of first difference or second difference. We will come to that later on. The time series x t, which I am denoting, is linear process if it can be represented by this function for some value of t, such that the z t which you have is linear process generally you will have, and that is basically true for when you are trying to find out the concept of the derivative pricing and all these things, or general linear process with a corresponding mean value of 0 and a standard deviation or a variance of sigma square. And this sequence is a sequence of constant such that it is always bounded, mod of that sum of that is always bounded and less than equal to infinity, and you can choose this constant depending on how you want to simulate and using the Monte Carlo simulation in order to basically have a whole gamut of different type of scenarios being generated in front of you. A linear process would basically have a moving average, which moving average should be constant, and if it is not, obviously the first moment would not exist. And let me go back to the slide. So, if I consider this, I am considering, see for example, for the time series. So, time series which I have, I am taking a small sample set. So, this is the time series which I have, right. So, the x values which you have are 0 to 2500 are the data points. So, they can be marked with respect to the date, which I am not doing. Now, interestingly, if I consider this whole time series, let me consider the right. So, if I consider the values wait, this is done. Now, if I zoom in here, so they are giving for each day. So, they are technically discrete, but what we are considering, the time series can be replicated in such a way that it can be considered as a continuous stochastic process. I am using the word stochastic process for the first time. It will be considered as a continuous stochastic process, which can be implemented for trying to basically find out how the model looks like. Now, what I mentioned was, which I have already drawn, is this. When I consider the values x 1, x 2, x 3, these are the time series data. If I take the first difference, which is delta x, for the first time it will be x 2 minus x 1, then delta x for the second time period will be x 3 minus x 2, I can find. So, if you can find this as stationary, then I will use the first difference or the second difference to find out the stationary process and do the studies such that we can find out the properties and proceed accordingly. So, this first difference and second difference concept is very important, which I just mentioned. I will handle it accordingly in the subsequent class. With this, I will end this 53rd lecture and continue discussing about the data for the time series later. Thank you very much and have a nice day.